Hello, everyone. Uh, so I want to talk about can AI agents act like scientists? But before going through my talk, I wanted to thank the organizers. The timing of this conference couldn't be better for me. I'm not sure about you, but I really thank you, Daryl and Buruz, for I know it's so much work, and thank you very much. So there has been a recent increasing interest in the idea of AI scientists, highlighted by a series of publications this year alone, 2026, in Nature. None of them is mine, so don't look for my name there. But it just shows how the space is developing. In social science, there is a parallel activities in social science. We don't have an AI scientist or AI co-scientist for social science yet, but there are scholars actively exploring part of the research pipeline to automate pipeline, the part of the research pipeline. And then it's very important here to distinguish between what we have heard about the capabilities of LLMs in social science and the capabilities of AI agents in social science. So I just submitted a paper to a journal, and one of the reviews I received, the reviewer totally mixed these two things up. So when we were talking about the capabilities of LLMs in social science, the sort of research questions we had were whether LLMs can do text annotation for us, classification, silicon sampling, stuff like that. And then the evaluation we were looking for was like the accuracy, intercoder agreement, cost. But when we talk about LLM agents, we are seeking agency. So if LLMs are engine, LLM agents are the car, which can take us to somewhere. And then, so here in agents, the sort of research questions we are interested in is that whether AI agents can reproduce a published paper, whether they can replicate the already published paper with the new data. And then the sort of evaluation we are looking for here, it's not that much accuracy. It can be, but we are more interested in whether they do p-hacking, whether they know a lot of methods as a typical social science researcher. So when you hear about AI agents in social science, it can be multiple things. It can be just a simple agent that the researcher built for themselves, or all of these AI companies, they have a AI for science team, and they are building agents for science. It can be one of those. But recently, these AI coding agents, whatever I'm going to present today is based on the AI coding agents. And AI coding agents are Claude Code, Codex, and other stuff, but my focus is on Claude Code and Codex. They are not considered as AI scientists yet, but apparently they have some capabilities which can be explored in this space. The first paper we started in this space was a multi-author paper. So here we just try to explore the idea of building AI co-scientists for social science. So we try to briefly summarize the risks, the challenges, the recommendation, the methodological boundaries. I'm not going to talk about this. It's just here to show. The paper is on my website. We received mixed reviews for this paper from something like the timing is very good. I enjoyed reading the paper, to the First one, which could be my ex, saying that I think overall this was a good thing for us to write for themselves and their students to stimulate this cognition. So this was a good experience for us, like to see how people in the field are seeing this kind of stuff, and it's a mix. So here we try to say in the paper that social science is unique in some ways and try to articulate those uniqueness of social science. But even in that space, we couldn't convince the reviewers, and one of the reviewers is saying that I'm not convinced that social science is unique in those ways that you are saying, but reviewer 3 and reviewer 4 saying that, yeah, this is exactly what we need. So there is a disagreement, and we have a hard work to go ahead. The second paper is about whether AI coding agents can reproduce a published social science findings. So this is different from whether social science publications are reproducible. That's the Nature paper, came out 2 months ago, showed that more than half of the social science publications are not reproducible. That is something else. Here, we want to say that if a paper is reproducible, can AI coding agents reproduce the results provided only code and data, not even the paper? So what we did here was to create a new benchmark based on 54 papers across many social science disciplines. I'm not going through very details, but what we found was that Claude Code can reproduce social science finding with more than 90% accuracy, and Codex around 80%. And to show that it is not only coming from their memory or training data, we ask both coding agents to infer the metadata of the papers, like the title, the publication year, the authors, and the journal. And the success rate among both AI coding agents was very low. So this is some evidence that the great performance in reproducibility are not the direct effect of memorization of the AI agents, and that the superiority of Claude Code doesn't come from its training the data because they are. Because actually when we asked AI agents to infer the main metadata, Codex is better than Claude Code. And we also test whether the performance is different before the training cutoff of these models and after that. And then, as we can see, the performance is same. We test this again based on the early online publications of the paper, again the same. So whatever this performance in reproducibility come from, it doesn't seem to be from the training data or the memorization. And then to show you how impressive this 90% or 80% are, so the core bench is the first kind of a thing in this space, came in 2024 by a couple of researchers at Princeton. Their first paper came out in 2024, and if you look at the paper, the best performance in terms of the accuracy and reproducibility was around 40 to 50%. And then the newest version came out a couple of months ago, 2026. If you look at the paper, again, the best accuracy is around 60%. We tried the same benchmark with AI coding agents, and we show that if we provide the PDF of the paper, the accuracy is 100%, which they have. In all of these, even the PDF of the paper is given to the AI agents. But in the slides I showed you, we don't give, because we want to examine the capability of them in reproducing, so we should not give the PDF to them. And then if we don't give, we don't provide the PDF, the accuracy in Claude Code is around 88, and for Codex 79. This is just, again, a case to differentiate between LLM agents and AI coding agents. These two are LLM agents, like AutoGPT, if you remember from 2025. But my results is based on AI coding agents, Claude Code and Codex. Going to the third paper, so after reproducibility, we go to replication and methodological diversity. Here, the concern, as Alex discussed yesterday, so one of the concerns in using AI agents in scientific discovery is AI homogenization. So we know for a fact that LLMs often fail to show human-like creativity in open-ended tasks that do not have a ground truth and answer. So one of the most famous paper in this space is here, the idea of artificial hive mind. So here, people say that if LLMs are not as creative as humans in these open-ended tasks, so in those scientific discovery tasks that are similar to this, using AI would create a homogenization. All of them would use a similar logic regression or OLS regression, and then they all converge to a similar result. The second concern in this space is the idea that these agents have lots of freedom, degree of freedom. They go and look for a lot of combinations of how to build a model, and they do p-hacking, or like they try to be, look, the idea of sycophancy, they try to be, to make us happy. We argue that most people think about this too as if they are one concern, but we are saying that no, these are two different concerns targeting two different layers of analysis. So the first layer, when we ask AI agents to do the research for us, is the design layer. The design is everything from the measurement, sampling, model specification, estimator, uncertainty, robustness checks. All of these are at the design layer. So whether the model is OLS, logit, fixed effect, the sample is all the countries or just a subsample, all of these are at the design layer. And then at the verdict layer, whatever estimate came from the design layer, thank you. At the verdict layer, then we need a decision rule. So for example, if 4 out of the 6 estimates were statistically significant at the 5%, then accept the hypothesis, so something like this. And then the substantive verdict that whether AI agents truthfully implement this decision rule. So to heads up, the results we found show that usually there is a difference between AI agents and humans in how they engage in p-hacking. So there is a lot of slides. I'm not going to cover them because the time is almost over. But the humans seem to engage in p-hacking at the design layer, but the AI agents at the verdict layer. So let's show you some examples. So to test this idea, we used this multi-researcher experiment. This is a 2022 PNAS paper. They invited 70 research teams from across the world, and then they give all teams same data set and same original paper about the idea of whether immigration undermines public support for social policy. And then they asked all of the research teams to replicate the results with new data. And what came out is this: 1,253 unique estimates. And this shows the spectrum of diversity in terms of the outcome of the humans. So the question is, if instead of humans, we ask AI coding agents to do the same, how would this plot look like? And the answer is this. So the top one is humans, the middle one is codex. So we can see that the codex is very similar to humans in terms of the diversity of the models. The bottom one is Claude Code, and we can see that Claude Code produced 3 times more model specifications compared to humans and codex. So the takeaway here is that whatever AI homogenization means, at least this plot based on this one single study doesn't support that in methodological diversity of these AI coding agents. And then here we see, okay, the diversity is similar to humans or even more than them, but how about the accuracy? Are the estimates close to those estimates that humans are producing? We test with, here we show that pretty much yes, more details in the paper. And then the next question is that, okay, how similar are these models produced by AI agents to humans? So the original paper did a great job in terms of identifying 15 methodological decisions that explain much of the variability in the methodological choices of the human researchers. And then based on those 15 method decisions, we compare the AI agents to humans. So the idea is, how similar are the models created by AI agents to the humans? Are just they copy-pasting those 73 research teams? Or no, they are coming up with new models for themselves. And then the answer is there is too much difference between the methods, the whole method part created by AI agents to those of humans. And not even single model produced by AI agents was exactly similar to the humans. And the highest Jacquard similarity between a model produced by agents and human is around 75%. So again, no sign of homogenization or whatever. So the next question is, should I stop or? Yeah, all right. I stop here.
Thanks for being flexible on time, Meysam. So we have time for a couple questions now.
What's your next research question?
Hi, very interesting results. I'm curious about what is a summary of your next research question? And
yeah, it comes from the limitation of this one, which is only based on one study. So whatever I'm presenting in the third paper is only based on one hypothesis and one data. So I'm going to expand it to show it's whether generalizable to when we, for example, analyzed 50 paper, would we see the similar patterns or not? Yeah.
thank you.
Sure.
Just a quick question. So you said humans do peak hacking at the design level, whereas LLMs usually commit to that at the verdict layer. And I am curious, can I use like an LLM to design something for me and go up until the verdict layer, but then put a human in the loop and then have that human do the like decision making? Or that's not how it's supposed to work?
So the right plot show that when we induce a biased prompt to AI agents saying that, hey, you are a researcher who are anti-immigrant and you believe that immigration should be tougher, immigration law should be tougher. We see no difference between the biased version of agents and the neutral version of agents in terms of the average estimates. So those four numbers are the comparing. But the 2 4 numbers are for humans. And you can see that large brown bars are for humans. So here it shows that those anti-immigrant humans, they do whatever they can to produce larger estimates so that it would be more convincible for the to accept the hypothesis. But if I could go to the last slide, the implication is that when we are using AI agents for scientific discovery, we need to make sure that they register and log everything. Because one of the ways that AI agents do p-hacking is by avoiding to write up a decision rule. Just you tell the agents that you have to first register your design and then go to the execution part, but it just ignored that because it knows at the end of the stage it needs that. Yeah. So humans are doing a lot of things to produce larger estimates. Agents don't do that, leave it for the last part, and they just software or avoid the decision rule.
Thanks, Meysam.
Thank you.